important, but let's see what we got. And actually, there's an opportunity for in-class extra credit coming up. So listen up. You're going to get to do one of these on your own. So we're going to do another stoichiometric calculation. And all stoichiometric calculations is going from the amount of something to the amount of something else. And we talked about that on Wednesday. And then on Wednesday, we did some moles to moles conversions. And actually, that's what your homework was. You went from moles of something to moles of something else. It's a stoichiometric calculation. So we're going to switch it up a little bit. This is that same chemical reaction between magnesium and oxygen that you guys did in the chem lab. That was the burning of magnesium oxide. But instead of going from moles of something to moles of something else, we're going to go from grams of something to grams of something else. And this is more typical of stoichiometric calculations. So I usually find magnesium on my balanced chemical equation, and underneath it I'll write 0.30 grams. Okay. And the question is, what mass of oxygen is needed? So I'll find my oxygen and I'll write question mark grams under my oxygen. So basically, if we were baking a cake, those would be 2 ingredients, right? Or baking brownies, okay? So basically, if you're going to use 0.30 grams of magnesium, how much oxygen are you going to need to use to form your magnesium oxide? Now, what we did last time was to go from moles to moles, okay, using a stoichiometric ratio from the coefficients of the balanced equation. Of course, if you look back at the coefficient in front of magnesium, hopefully you would tell me it's 2, and the coefficient in front of the O2 is 1. So we know that that's kind of the relative amount that they react on a mole basis, okay? But you can't go from grams, like the 0.30 grams of magnesium, you can't go straight to grams of oxygen using a stoichiometric ratio. Okay? So instead, this is kind of the flow of things. And if you're looking for a pattern in this sort of chemistry problem, there definitely is a pattern. So we're going to go from the grams of magnesium, which is what we have. We have to go through moles, and we know how to do that. We know we can go from grams, that 0.30 grams of magnesium, to moles of magnesium using magnesium's molar mass, which is one of my favorite phrases in Intro Gen Chem. Molar mass of magnesium. Okay, so we'll get that from the periodic table. So now once we have moles of magnesium, it's back to the problem like we did on Wednesday. We can go from moles of magnesium to moles of the other reactant, O2, using a ratio, stoichiometric ratio. Goodness, looks like we're going to have what? 1 mole of O2 over 2 moles of Mg. That's going to actually go there. And that will give us to moles of O2, but we want to take it all the way to grams of O2. So then we have one last kind of thing to tack on. We're going to have to use the molar mass now of O2 to finish off the problem. Okay, so stoichiometric calculations where you're going from grams of something to grams of something else always have this pattern. Some chemistry problems, there's no obvious pattern. This, there is an obvious pattern. You're going to use the molar mass on the front end of what you know the mass of, use a stoichiometric ratio, and then you're going to use the molar mass of what you're trying to get to on the back end. And that's it. So let's work this problem. And so using the periodic table, I'm going to go ahead and knock out the molar masses of everything. So the molar mass of magnesium is the decimal number for magnesium on the periodic table, 24.31 grams per mole. The molar mass of molecular oxygen, molar mass of O2, we take 2 times the decimal number of oxygen, 16.00, for a total molar mass of 32.00 grams per mole. And we don't need it right now, but we will for the next problem, kind of a follow-up problem to the same reaction. The molar mass of the product, molar mass of magnesium oxide, is the decimal number for magnesium, 24.31, plus the decimal number for oxygen, 16.00. So the molar mass for magnesium oxide is 40.31. I'm going to try something new this semester. I'm going to point out something that I see students have kind of a pitfall on this. So do you buy this, that when we were coming up, for instance, with the molar mass of magnesium, okay, we did not care that the recipe, in this case, molar mass of magnesium oxide, We did not care that it formed 2 moles of magnesium oxide in this particular chemical reaction. We only wanted the molar mass of MgO. So we took 1 times magnesium plus 1 times oxygen. Okay, so anyway, all right, so let's go ahead and work this problem. You can go ahead and break it up into 3 steps, but a lot of times I just kind of string up the terms, just like you kind of saw the flow of it go. I need to be explicit. I need to say what's the masses and what are the molar masses. So for instance, the first term is going to be the mass of magnesium over 1. So I can't just put 0.30 grams. I have to put 0.30 grams Mg, okay, over 1. Then we said we need to get from grams to moles, so we're going to use the molar mass of magnesium. And we want grams to cancel, so we're going to put that 24.31 grams on the bottom, 24.31 grams magnesium, and the top we're going to put 1 mole of magnesium. So now our grams of magnesium canceled, we're left with moles of magnesium. Now we're ready to go to moles of O2. And this again is kind of what we did on Wednesday, excuse me. So now this is where we go. Remember we talked about revisiting the stoichiometric coefficients. We said this means that 2 moles of magnesium will react with 1 mole of O2. So we want moles of magnesium to cancel, so we're going to put 2 moles of magnesium on the bottom, 1 mole of O2 on top. Doing it that way, units, not numbers, but units of moles of magnesium cancel. We're left with units of moles of O2, and we're almost done. On the previous slide, we knocked out the molar mass for O2 is 32.00 grams per mole. So we have to again be explicit, so we're going to put 32.00 grams of O2 per 1 mole of O2. Moles of O2 cancel, we're left with grams of O2. So again, it's a very characteristic sort of pattern, going from grams of something to grams of something else. So in our calculators, we have several numbers in the numerator and a few numbers in the denominator. So basically, we need to take 0.3 times 1 times 1 times 32.00 divided by 24.31 times 2. And that will give us a number. We need to round according to, looks like 2 sig figs. This 2 brings no uncertainty because it's a exact number. So 2 sig figs, and our units are going to be grams of O2. Remember, when you're kind of doing that in your calculator, some students like to kind of multiply all the things on top, write that down, multiply all the things on the bottom, write that down, and do one last division. Some people do that. So round to 2 sig figs, I get 0.20 grams of O2. So again, it's kind of like a recipe sort of thing. It's like if you have 0.30 grams of magnesium in your cupboard, you're going to use up 0.20 grams of O2. That's it. That's it. So we're going to do a few of those, and then I'm going to turn you loose on one for extra credit. So let's stick with the same balanced equation. Let's kind of change it up a little bit. In this case, it says what mass of magnesium oxide. So I find magnesium oxide and I put question mark grams. What mass of magnesium oxide is produced when we have that same mass of magnesium, 0.30 grams of magnesium. And this one says sufficient oxygen. We'll talk more about that on Monday. So under the oxygen, I'm going to put enough, sufficient. We're not going to run out of O2. And we just did a calculation that says you at least have to have 0.20 grams of O2, and we have at least that much. So, I think I do this. So kind of the way we're going to do this, I'll kind of diagram it up here. We are going to go from grams of Mg to moles of Mg. Using the molar mass of Mg. And once we have the moles of magnesium, So grams of mg to moles of mg using the molar mass, mg. And then we're going to go from moles of magnesium now to moles of magnesium oxide using stoichiometric ratio, stoich ratio. And then we're going to go from moles of magnesium oxide to grams of magnesium oxide using magnesium oxide's molar mass. All right, let's do this thing. So the first number is going to be that 0.30 grams of magnesium over 1. Then we're going to use the molar mass of magnesium from the periodic table. We want grams to cancel, be left with moles. So it'll be 1 mole of magnesium over 24.31 grams of magnesium. It looks the same as the last problem we did, doesn't it? So now we need moles of magnesium to cancel, be left with units of moles of magnesium oxide. So here again is where now we're going to focus on this step. We focus on the relative number of moles of each, which is a 2 to 2. And I would leave it 2 to 2 instead of reducing it personally. So we're going to put 2 moles of magnesium on the bottom and 2 moles of magnesium oxide on the top. And that means our moles of magnesium have canceled. And we're almost done. This is why a few slides ago we went ahead and knocked out the molar mass of magnesium oxide. So we want moles to cancel, so we're going to put grams over moles for the molar mass of magnesium oxide. So now moles cancel. Looking for Kleenexes?
Yeah.
Yeah. Anybody have Kleenexes?
No, but there's some in the bathroom.
Oh, in the bathroom. Okay. So, all units cancel. All units report. All units cancel except for grams of magnesium oxide. Looks like we need to round according to 2 sig figs again. So you should get, maybe not so surprising, 0.50 grams. Some of you might be saying, well, Mrs. Snipes, due to the conservation of mass, actually you knew it was going to be 0.50 grams. And you're right. Because we did a previous calculation, we knew 0.30 grams of magnesium would react with 0.20 grams of O2. And mass has to be conserved, so that gives us 0.50 grams in that case, that same scenario of product. So if you're ever faced with this sort of situation, actually you can do what's called a mass balance and come up with the same grams on either side of the reaction arrow. Sometimes students will ask me, well, Mrs. Snipes, if I have this on the test, can I just by difference get the product? And you won't have one of these like this on the test. But it's nice to keep in the back of your head, your mind. Okay, so that's that one. So practice makes perfect, right? So actually, if you don't mind, we're going to skip this beast, and I think we're going to open up with this one on Monday. So, is this the next one that you guys have? Okay. So, do you guys have this one after that? So you need to go forward a few slides. Okay. Cool. So I'd like to do this one together. Now we're switching gears. It's a different reaction, a different balanced chemical equation. Yes, this is balanced, and you guys had some work at balancing equations. Okay. If we look on either side of the reaction arrow, you know, and I think I did this one actually. If you count P's and CL's, you have, what, 4 and 12 and 4 and 12. All right. Because you can only do stoichiometric calculations if you have the right recipe, the right set of coefficients that balances it. So I think we saw this one not too long ago, so I'm not going to belabor that. Let's go right to the problem. So we're going to do problem number 1 together, and then actually problem number 2, I'm going to turn you loose for hand it in for 5 extra credit points. So let's look at the first one. What's it after? Well, Again, you know, if you already have the balanced chemical equation, there's a lot of chemistry problems that if you already have that concisely written, it's kind of a nice framework to go ahead and write your question. So it says, what mass of P4 is needed? So I'll find P4, I'll write question mark grams. What mass of P4 is needed to react with 1.25 grams of Cl2? So if I was diagramming this, kind of like we've done before, we're going to go from grams of Cl2 to moles of Cl2 using its molar mass. And then we're going to go from moles of Cl2 to moles of P4 using the stoichiometric ratio. And I will tell you, we have, what, 6 moles of Cl2 reacting with 1 mole of P4. That's where our stoichiometric ratio is going to come from. So stoich ratio. And then we're going to finish off going from moles to grams using molar mass. So we're going to go from moles of P4 to grams of P4 using its molar mass. So kind of like I did before, I'm going to have a slide that knocks out molar mass of Cl2, P4, and PCl3. So I don't know if you guys have these. Did you already have these? Okay, good. So we got these from the periodic table. We took 4 times the decimal number for phosphorus to get the molar mass of P4, 2 times the decimal number for chlorine to get the molar mass of Cl2, and similarly the molar mass of PCl3. So here we go. So our first term is going to be that 1.25 grams of Cl2 over 1. And then we decided we know to go from grams to moles. So we're going to use what I call the flipped version of the molar mass of Cl2 on the previous slide. So we're going to put 1 mole of Cl2 over 70.90 grams of Cl2. So now grams of Cl2 have canceled. We're in good shape. Now is kind of what I call the heart of the stoichiometric calculation. We're going to use a ratio from the balanced chemical equation. That 6 means 6 moles of Cl2. So that's actually going to go on the bottom. The implied 1 in front of the P4 means 1 mole of P4, so that's going to go on top. So we have 1 mole of P4 over 6 moles of Cl2. Moles of Cl2 cancel. And we're almost done. To get from moles to grams, we've been talking the last couple of units, we can use the molar mass of P4, the non-flipped version. So a few slides ago, we had it as 123.88 grams of P4 for 1 mole of P4. Moles of P4 cancel. Unit-wise, we are in great shape because that's what we wanted, grams of P4. So it looks like on the numerator, we need to take 1.25 times 123.88. In the denominator, we need to divide that by the product of 70.90 times 6. Rounding it to, what, 3 sig figs? I'm liking 3 sig figs. Okay. You should come up with the mass of the other ingredient, the mass of the other reactant, to react with 1.25 grams of Cl2 is 0.364 grams of P4. Okay. So now I'm going to give you a little bit of time, and you're going to work this problem. 1.25, and you can't do it by addition. You can't just add 1.25 times plus that other one. 1.25 grams of Cl2, what mass of PCl3 will be produced? And I'll go ahead and put enough or sufficient under P4. So work that problem. It's going to be very similar to the ones we've been working.
Yeah, as before, when you add it together, but you can increase something.
Awesome. Well, if y'all were balancing your checkbook, you all would know you're on track because you came up with the same number. So good job. Very good. I think we're going to go with 10 extra credit points for this just because I can. Like I said, we're going to come back on Monday before we go finish this part. And Monday, actually, we'll start in on solution concentration, too. But in the meantime, these problems, is this your assignment slide? Do you have these three? Okay, good. So we'll take a quick look at these. These will do on Monday. They're more fun. I'm just saying. Let's take a look at what they look like. 18.35. Where did it go? Looks like this one. Okay, so it's going to really look familiar as to what the problems that you guys just did, okay? What I would suggest is when you work these, I would rewrite the balanced chemical equation. You got all weekend, you know. I would, because I just think it helps kind of clarify. And then, let's see, show how many grams of each product. Oh my goodness. Okay, so basically for each one of these, you have two questions. Like, so for instance, A, okay, you have 4.7 grams of aluminum, and you're supposed to go after grams of aluminum oxide and grams of iron. Okay, does that make sense? Yep. And for the next one, you have 4.7. I wish they had made a different mass, because that's going to be confusing. The next one, it changes up. You have the same mass, but it's of the other reactant. And you're supposed to go for grams. So actually, there's 4 stoichiometric calculations right there. Okay? So that's the first one. The next one, calculate how many grams of each product. Oh my gosh. Okay. Let's go ahead and just do, I'm changing it up. Instead of each product, how many grams of, let's see, what should we pick? How many grams of NaCl? Because that's just ridiculous. Yeah. How many grams of NaCl? They're fun, but they're not that fun. Okay? So you'll have 2 problems here. In the first one, you have, again, I don't know why they go with the same masses. In the first one, you'll have 10.8 grams of HCl. You're supposed to get to the grams of NaCl. And in the second one, you'll have 10.8 grams of the other reactant, and you're supposed to get to the grams of NaCl. So only 2 problems there. And last but not least, looks like this. I think probably we'll just leave it as it is. So it says that you're dissolving solid aluminum in sulfuric acid. We worked with sulfuric acid yesterday, didn't we? And it says, let's just say that you know that you have a mass of aluminum as 22.5 grams. There's, think 2 questions, and we'll do both of them. The first question is, what's the minimum amount of H2SO4 you need? Bless you. So that goes like this, grams of H2SO4 you need to dissolve 22.5 grams, kind of a practical sort of thing. And then a follow-up question is, how many grams of H2 will be produced? So, question mark grams. So you had 2 here, 2 on the previous, and 4. That's 8. You can do it. Great. Okay. So, and we're quitting early. So there you go.